Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
For this question, refer to the Terramirth case study. Terramirth has decided to store data files in cloud storage. You need to configure Cloud Storage Lifecycle Rule to store 1 year of data and minimize file storage cost. Which two actions should you take? The options are: Option A, create a Cloud Storage Lifecycle Rule with age 30, storage class, standard, and action, set to Coldline, and create a second GCS Lifecycle Rule with age 365, storage class, Coldline, and action, delete. Option B, create a Cloud Storage Lifecycle Rule with age 30, storage class, Coldline, and action, set to Nearline, and create a second GCS Lifecycle Rule with age 91, storage class, Coldline, and action, set to Nearline. Option C, create a Cloud Storage Lifecycle Rule with age 90, storage class, standard, and action, set to Nearline, and create a second GCS Lifecycle Rule with age 91, storage class, Nearline, and action, set to Coldline. Option D, create a Cloud Storage Lifecycle Rule with age 30, storage class, standard, and action, set to Coldline, and create a second GCS Lifecycle Rule with age 365, storage class, Nearline, and action, delete.
To arrive at the correct answer, we focus on the keywords: store data files in cloud storage, configure Cloud Storage Lifecycle Rule, store 1 year of data, minimize file storage cost.
The correct answer is option A, create a Cloud Storage Lifecycle Rule with age 30, storage class, standard, and action, set to Coldline, and create a second GCS Lifecycle Rule with age 365, storage class, Coldline, and action, delete.
Why is this correct? A. Moving data from standard to Coldline storage after 30 days significantly lowers storage costs while maintaining availability, and setting a deletion rule at 365 days ensures data is retained for exactly 1 year. Why are the others incorrect? B. Transitioning objects from Coldline back to Nearline increases storage costs unnecessarily, and it fails to delete the files after 1 year. C. Moving to Nearline after 90 days delays cost savings compared to 30 days, and it lacks the deletion rule required to limit data retention to 1 year. D. The deletion rule targets Nearline storage instead of Coldline storage, meaning the files transitioned to Coldline will never be deleted after 365 days.
For this question, refer to the Terramirth case study. You need to implement a reliable, scalable GCP solution for the data warehouse for your company, Terramirth. Considering the Terramirth business and technical requirements, what should you do? The options are: Option A, replace the existing data warehouse with BigQuery. Use table partitioning. Option B, replace the existing data warehouse with a compute engine instance with 96 CPUs. Option C, replace the existing data warehouse with BigQuery. Use federated data sources. Option D, replace the existing data warehouse with a compute engine instance with 96 CPUs. Add an additional compute engine preemptible instance with 32 CPUs.
To arrive at the correct answer, we focus on the keywords: reliable, scalable GCP solution for the data warehouse, business and technical requirements.
The correct answer is option A, replace the existing data warehouse with BigQuery. Use table partitioning.
Why is this correct? A. BigQuery is Google Cloud's fully managed, serverless data warehouse designed for extreme scale and reliability. Implementing table partitioning optimizes query performance and significantly reduces costs when analyzing Terramirth's massive volume of time series telematics data. Why are the others incorrect? B. Compute Engine is an infrastructure as a service offering that requires manual administration and lacks the automated scaling, native high availability, and serverless analytics capabilities of BigQuery. C. Querying federated data sources introduces network overhead and higher latency, making it less performant for core data warehousing tasks compared to storing and partitioning data directly within BigQuery. D. Compute Engine instances require complex maintenance and lack native warehouse scalability. Preemptible instances can be terminated at any time, compromising the reliability required for a data warehouse.
For this question, refer to the Terramirth case study. A new architecture that writes all incoming data to BigQuery has been introduced. You notice that the data is dirty, and want to ensure data quality on an automated daily basis while managing cost. What should you do? The options are: Option A, set up a streaming cloud dataflow job, receiving data by the ingestion process. Clean the data in a cloud dataflow pipeline. Option B, create a cloud function that reads data from BigQuery and cleans it. Trigger the cloud function from a compute engine instance. Option C, create a SQL statement on the data in BigQuery and save it as a view. Run the view daily and save the result to a new table. Option D, use Cloud Data Prep and configure the BigQuery tables as the source. Schedule a daily job to clean the data.
To arrive at the correct answer, we focus on the keywords: writes all incoming data to BigQuery, data is dirty, ensure data quality on an automated daily basis, managing cost.
Correct answer is option D, use Cloud Data Prep and configure the BigQuery tables as the source. Schedule a daily job to clean the data.
Why is this correct? D. Cloud Data Prep is purpose-built for data cleaning and preparation. It directly integrates with BigQuery and supports scheduling automated daily jobs, which perfectly aligns with the requirement to manage costs by running periodically instead of continuously. Why are the others incorrect? A. A streaming cloud dataflow job runs continuously 24/7, which significantly increases costs compared to a daily scheduled job, violating the cost management requirement. B. Cloud functions have execution time and memory limits, making them unsuitable for processing large BigQuery datasets. Triggering via compute engine adds unnecessary operational overhead. C. Creating a SQL view and managing daily execution to a new table is complex and less robust for comprehensive data cleansing compared to Cloud Data Prep's built-in scheduling and specialized data quality features.
For this question, refer to the Terramirth case study. Considering the technical requirements, how should you reduce the unplanned vehicle downtime in GCP? The options are: Option A, use BigQuery as the data warehouse. Connect all vehicles to the network and stream data into BigQuery using Cloud Pub/Sub and Cloud Dataflow. Use Google Data Studio for analysis and reporting. Option B, use BigQuery as the data warehouse. Connect all vehicles to the network and upload gzip files to a multi-regional cloud storage bucket using Cloud. Use Google Data Studio for analysis and reporting. Option C, use Cloud Dataproc Hive as the data warehouse. Upload gzip files to a multi-regional cloud storage bucket. Upload this data into BigQuery using Cloud. Use Google Data Studio for analysis and reporting. Option D, use Cloud Dataproc Hive as the data warehouse. Directly stream data into partitioned Hive tables. Use Pig scripts to analyze data.
To arrive at the correct answer, we focus on the keywords: technical requirements, reduce the unplanned vehicle downtime.
The correct answer is option A, use BigQuery as the data warehouse. Connect all vehicles to the network and stream data into BigQuery using Cloud Pub/Sub and Cloud Dataflow. Use Google Data Studio for analysis and reporting.
Why is this correct? A. Streaming telemetry data via Cloud Pub/Sub and Cloud Dataflow into BigQuery enables real-time data ingestion and predictive analytics, allowing immediate detection of vehicle issues to minimize unplanned downtime. Why are the others incorrect? B. Batch uploading gzip files via Cloud does not support real-time streaming, preventing immediate predictive maintenance required to prevent unplanned downtime. C. Using Cloud Dataproc Hive adds unnecessary operational complexity, and batch file uploads fail to provide real-time streaming required for prompt anomaly detection. D. Cloud Dataproc Hive with Pig scripts is designed for batch processing rather than scalable real-time ingestion and low-latency visualization.
For this question, refer to the Terramirth case study. You are asked to design a new architecture for the ingestion of the data of the 200,000 vehicles that are connected to a cellular network. You want to follow Google recommended practices, considering the technical requirements. Which components should you use for the ingestion of the data? The options are: Option A, Google Kubernetes Engine with an SSL ingress. Option B, Cloud IoT Core with public/private key pairs. Option C, Compute Engine with project-wide SSH keys. Option D, Compute Engine with specific SSH keys.
To arrive at the correct answer, we focus on the keywords: ingestion of the data of the 200,000 vehicles, ingestion of the data connected to a cellular network, Google recommended practices.
The correct answer is option B, Cloud IoT Core with public/private key pairs.
Why is this correct? B. Cloud IoT Core is specifically designed for securely connecting, managing, and ingesting telemetry data from large fleets of IoT devices like connected vehicles using public/private key authentication at scale. Why are the others incorrect? A. GKE with SSL ingress requires manual architecture management and lacks built-in IoT device registry and authentication features provided by Cloud IoT Core. C. Compute Engine with project-wide SSH keys is unscalable and insecure for managing individual device authentication and ingesting data from 200,000 vehicles. D. Compute Engine with specific SSH keys does not provide a managed solution for device telemetry ingestion and is difficult to scale for 200,000 vehicles.
For this question, refer to the Terramirth case study. You start to build a new application that uses a few cloud functions for the backend. One use case requires a cloud function func_display to invoke another cloud function func_query. You want func_query only to accept invocations from func_display. You also want to follow Google's recommended best practices. What should you do? The options are: Option A, create a token and pass it in as an environment variable to func_display. When invoking func_query, include the token in the request. Pass the same token to func_query and reject the invocation if the tokens are different. Option B, make func_query require authentication. Create a unique service account and associate it to func_display. Grant the service account invoker role for func_query. Create an ID token in func_display and include the token to the request when invoking func_query. Option C, make func_query require authentication and only accept internal traffic. Create those two functions in the same VPC. Create an ingress firewall rule for func_query to only allow traffic from func_display. Option D, create those two functions in the same project and VPC. Make func_query only accept internal traffic. Create an ingress firewall for func_query to only allow traffic from func_display. Also, make sure both functions use the same service account.
To arrive at the correct answer, we focus on the keywords: cloud functions for the backend, func_display to invoke another cloud function func_query, only to accept invocations from func_display, Google's recommended best practices.
The correct answer is option B, make func_query require authentication. Create a unique service account and associate it to func_display. Grant the service account invoker role for func_query. Create an ID token in func_display and include the token to the request when invoking func_query.
Why is this correct? B. Google recommends enforcing IAM authentication on the receiving function, assigning a dedicated service account to the calling function with the cloud function's invoker role, and fetching a Google Sign ID token to authenticate function-to-function HTTP requests securely. Why are the others incorrect? A. Using custom tokens in environment variables is insecure, hard to manage, and violates Google's standard IAM authentication best practices. C. Firewall rules operate at the network layer and cannot filter traffic based on individual serverless cloud function identities. D. Sharing the same service account violates the principle of least privilege, and VPC firewall rules cannot directly inspect or filter cloud function service identities.
For this question, refer to the Terramirth case study. You have broken down a legacy monolithic application into a few containerized RESTful microservices. You want to run those microservices on Cloud Run. You also want to make sure the services are highly available with low latency to your customers. What should you do? The options are: Option A, deploy Cloud Run services to multiple availability zones. Create cloud endpoints that point to the services. Create a global HTTP/S load balancing instance and attach the cloud endpoints to its backend. Option B, deploy Cloud Run services to multiple regions. Create serverless network endpoint groups pointing to the services. Add the serverless NEGs to a backend service that is used by a global HTTP/S load balancing instance. Option C, deploy Cloud Run services to multiple regions. In Cloud DNS, create a latency-based DNS name that points to the services. Option D, deploy Cloud Run services to multiple availability zones. Create a TCP/IP global load balancer. Add the Cloud Run endpoints to its backend service.
To arrive at the correct answer, we focus on the keywords: containerized RESTful microservices, microservices on Cloud Run, highly available with low latency.
The correct answer is option B, deploy Cloud Run services to multiple regions. Create serverless network endpoint groups pointing to the services. Add the serverless NEGs to a backend service that is used by a global HTTP/S load balancing instance.
Why is this correct? B. Cloud Run is a regional managed service. Deploying it across multiple regions and using serverless network endpoint groups, NEGs, with a global external HTTP/S load balancer provides multi-region high availability and optimal routing for low latency. Why are the others incorrect? A. Cloud Run is managed at the regional level, not specified by individual availability zones. Cloud endpoints are not used as backends for load balancing Cloud Run services across regions. C. Latency-based Cloud DNS routing lacks the advanced traffic routing, instant health checking, and seamless failover capabilities provided by a global HTTP/S load balancer with serverless NEGs. D. Cloud Run services host HTTP/REST workloads requiring an HTTP/S load balancer with serverless NEGs, rather than a Layer 4 TCP/IP global load balancer.
For this question, refer to the Terramirth case study. You are migrating a Linux-based application from your private data center to Google Cloud. The Terramirth security team sent you several recent Linux vulnerabilities published by Common Vulnerabilities and Exposures, CVE. You need assistance in understanding how these vulnerabilities could impact your migration. What should you do? Choose 2. The options are: Option A, open a support case regarding the CVE and chat with the support engineer. Option B, read the CVEs from the Google Cloud Status Dashboard to understand the impact. Option C, read the CVEs from the Google Cloud Platform Security Bulletins to understand the impact. Option D, post a question regarding the CVE in Stack Overflow to get an explanation. Option E, post a question regarding the CVE in a Google Cloud discussion group to get an explanation.
To arrive at the correct answer, we focus on the keywords: migrating a Linux-based application, Linux vulnerabilities published by Common Vulnerabilities and Exposures, CVE, how these vulnerabilities could impact your migration. Choose 2.
The correct answers are option A, open a support case regarding the CVE and chat with the support engineer. And option C, read the CVEs from the Google Cloud Platform Security Bulletins to understand the impact.
Why is this correct? A. Opening a support case allows direct, confidential consultation with Google Cloud engineers regarding specific CVE impacts on your environment. C. Google Cloud Platform Security Bulletins provide official advisories, vulnerability impacts, and remediation steps specific to Google Cloud services. Why are the others incorrect? B. The Google Cloud Status Dashboard tracks service outages and availability incidents, not security vulnerability impacts or security bulletins. D. Public forums like Stack Overflow are inappropriate for confidential enterprise security assessments and lack official Google security verification. E. Community discussion groups do not provide official security support from Google, and public postings can expose sensitive infrastructure information.
For this question, refer to the Terramirth case study. Terramirth has a legacy web application that you cannot migrate to cloud. However, you still want to build a cloud-native way to monitor the application. If the application goes down, you want the URL to point to a site is unavailable page as soon as possible. You also want your ops team to receive a notification for the issue. You need to build a reliable solution for minimum cost. What should you do? The options are: Option A, create a scheduled job in Cloud Run to invoke a container every minute. The container will check the application URL. If the application is down, switch the URL to the site is unavailable page and notify the ops team. Option B, create a cron job on a compute engine VM that runs every minute. The cron job invokes a Python program to check the application URL. If the application is down, switch the URL to the site is unavailable page and notify the ops team. Option C, create a cloud monitoring uptime check to validate the application URL. If it fails, put a message in a pub/sub queue that triggers a cloud function to switch the URL to the site is unavailable page and notify the ops team. Option D, use cloud error reporting to check the application URL. If the application is down, switch the URL to the site is unavailable page and notify the ops team.
To arrive at the correct answer, we focus on the keywords: legacy web application that you cannot migrate to cloud, cloud-native way to monitor the application, point to a site is unavailable page, ops team to receive a notification, reliable solution for minimum cost.
The correct answer is option C, create a cloud monitoring uptime check to validate the application URL. If it fails, put a message in a pub/sub queue that triggers a cloud function to switch the URL to the site is unavailable page and notify the ops team.
Why is this correct? C. Cloud monitoring uptime checks provide a managed, serverless, and cost-effective way to monitor URL availability. Triggering a cloud function via pub/sub upon failure enables automated remediation, switching the URL, and alerting with minimal operational overhead. Why are the others incorrect? A. Creating custom scheduled Cloud Run containers to poll a URL adds unnecessary architectural complexity and cost compared to native cloud monitoring uptime checks. B. Running a compute engine VM continuously for a cron job is not cloud native, incurs higher ongoing compute costs, and introduces a single point of failure. D. Cloud error reporting aggregates crash and log errors from applications. It cannot perform active external availability or uptime checks on a URL.
For this question, refer to the Terramirth case study. You are building a microservice-based application for Terramirth. The application is based on Docker containers. You want to follow Google recommended practices to build the application continuously and store the build artifacts. What should you do? The options are: Option A, configure a trigger in Cloud Build for new source changes. Invoke Cloud Build to build container images for each microservice, and tag them using the code commit hash. Push the images to the container registry. Option B, configure a trigger in Cloud Build for new source changes. The trigger invokes build jobs and build container images for the microservices. Tag the images with a version number and push them to cloud storage. Option C. Create a scheduler job to check the repo every minute. For any new change, invoke Cloud Build to build container images for the microservices. Tag the images using the current timestamp and push them to the container registry. Option D. Configure a trigger in Cloud Build for new source changes. Invoke Cloud Build to build one container image and tag the image with the label latest. Push the image to the container registry.
To arrive at the correct answer, we focus on the keywords: microservice-based application, Docker containers, Google recommended practices, build the application continuously and store the build artifacts.
The correct answer is option A. Configure a trigger in Cloud Build for new source changes. Invoke Cloud Build to build container images for each microservice, and tag them using the code commit hash. Push the images to the container registry.
Why is this correct? A. Cloud Build native triggers automatically detect repository changes. Google recommended practices suggest building distinct container images for each microservice, tagging them using commit hashes for precise traceability, and storing them in container registry, or artifact registry. Why are the others incorrect? B. Cloud storage is designed for general object storage, whereas container registry or artifact registry is the dedicated, recommended Google Cloud service for storing Docker container images. C. Polling a repository every minute using Cloud Scheduler is inefficient and unnecessary because Cloud Build provides native, event-driven build triggers for repository events. D. Building a single container image contradicts the requirement for a microservice-based architecture, and using only the latest tag prevents effective version tracking and rollbacks.
For this question, refer to the Terramirth case study. Terramirth has about 1 petabyte (PB) of vehicle testing data in a private data center. You want to move the data to cloud storage for your machine learning team. Currently, a 1 gigabit per second interconnect link is available for you. The machine learning team wants to start using the data in a month. What should you do? The options are: Option A, request transfer appliances from Google Cloud, export the data to appliances, and return the appliances to Google Cloud. Option B, configure the storage transfer service from Google Cloud to send the data from your data center to cloud storage. Option C, make sure there are no other users consuming the 1 gigabit per second link, and use multi-thread transfer to upload the data to cloud storage. Option D, export files to an encrypted USB device, send the device to Google Cloud, and request an import of the data to cloud storage.
To arrive at the correct answer, we focus on the keywords: 1 petabyte (PB) of vehicle testing data, move the data to cloud storage, 1 gigabit per second interconnect link, start using the data in a month.
The correct answer is option A, request transfer appliances from Google Cloud, export the data to appliances, and return the appliances to Google Cloud.
Why is this correct? A. Transferring 1 PB over a 1 gigabit per second link takes over 90 days theoretically. Using Google Cloud Transfer appliances provides the necessary bandwidth to securely migrate petabyte-scale data offline within the requested 1-month timeframe. Why are the others incorrect? B. Storage transfer service relies on network bandwidth. Sending 1 PB over a 1 gigabit per second link takes roughly 3 months, missing the 1-month deadline. C. Multithreading cannot overcome the physical limits of a 1 gigabit per second connection, which mathematically requires over 90 days to transfer 1 PB. D. Shipping standard USB drives is not a supported or scalable Google Cloud migration service for petabyte-scale datasets.
The Dress4Win security team has disabled external SSH access into production virtual machines, VMs, on Google Cloud Platform, GCP. The operations team needs to remotely manage the VMs, build and push Docker containers, and manage Google Cloud Storage objects. What can they do? The options are: Option A, grant the operations engineer access to use Google Cloud Shell. Option B, configure a VPN connection to GCP to allow SSH access to the cloud VMs. Option C. Develop a new access request process that grants temporary SSH access to cloud VMs when an operations engineer needs to perform a task. Option D. Have the development team build an API service that allows the operations team to execute specific remote procedure calls to accomplish their tasks.
To arrive at the correct answer, we focus on the keywords: disabled external SSH access into production virtual machines, VMs, remotely manage the VMs, build and push Docker containers, and manage Google Cloud Storage objects.
The correct answer is option A. Grant the operations engineer access to use Google Cloud Shell.
Why is this correct? A. Google Cloud Shell provides a browser-based command line interface equipped with pre-installed tools like Cloud, Docker, and SUDL. It allows administrators to manage resources, build containers, and interact with cloud storage without needing direct external SSH access to production VMs. Why are the others incorrect? B. Setting up a VPN to enable SSH bypasses and directly contradicts the security team's policy disabling external SSH access to production VMs. C. Granting temporary SSH access still violates the explicitly established security policy that restricts SSH access to production VMs. D. Custom API development creates unnecessary engineering overhead and maintenance complexity when Google Cloud Shell already provides the required management functionality natively.
At Dress4Win, an operations engineer wants to create a low-cost solution to remotely archive copies of database backup files. The database files are compressed tar files stored in their current data center. How should he proceed? The options are: Option A. Create a cron script using SUDL to copy the files to a cold-line storage bucket. Option B. Create a cron script using SUDL to copy the files to a regional storage bucket. Option C. Create a cloud storage transfer service job to copy the files to a cold-line storage bucket. Option D. Create a cloud storage transfer service job to copy the files to a regional storage bucket.
To arrive at the correct answer, we focus on the keywords: low-cost solution to remotely archive copies of database backup files, compressed tar files stored in their current data center.
The correct answer is option C. Create a cloud storage transfer service job to copy the files to a cold-line storage bucket.
Why is this correct? C. Cloud storage transfer service provides a managed, reliable way to transfer data from on-premises environments to GCP. Cold-line storage offers the most cost-effective storage class for infrequently accessed backup archives. Why are the others incorrect? A. Custom cron scripts using SUDL require manual maintenance and error handling, making them less reliable than the managed cloud storage transfer service. B. Writing custom cron scripts adds unnecessary operational overhead, and regional storage is significantly more expensive than cold-line storage for archival data. D. Regional storage is intended for high-frequency access and is not a cost-effective choice for long-term backup archiving compared to cold-line storage.
Dress4Win has asked you to recommend machine types they should deploy their application servers to. How should you proceed? The options are: Option A. Perform a mapping of the on-premises physical hardware cores and RAM to the nearest machine types in the cloud. Option B. Recommend that Dress4Win deploy application servers to machine types that offer the highest RAM to CPU ratio available. Option C. Recommend that Dress4Win deploy into production with the smallest instances available, monitor them over time, and scale the machine type up until the desired performance is reached. Option D. Identify the number of virtual cores and RAM associated with the application server virtual machines, align them to a custom machine type in the cloud, monitor performance, and scale the machine types up until the desired performance is reached.
To arrive at the correct answer, we focus on the keywords: recommend machine types, deploy their application servers.
The correct answer is option D. Identify the number of virtual cores and RAM associated with the application server virtual machines, align them to a custom machine type in the cloud, monitor performance, and scale the machine types up until the desired performance is reached.
Why is this correct? D. Sizing instances based on existing VM virtual cores and RAM using custom machine types. followed by monitoring and iterative adjustment, provides accurate resource allocation and cost optimization during migration. Why are the others incorrect? A. Mapping physical cores directly to cloud instances ignores virtualization ratios, leading to severe overprovisioning and unnecessary costs. B. Blindly choosing the highest RAM to CPU ratio without analyzing actual application workloads leads to suboptimal resource utilization and higher costs. C. Starting production deployment on the smallest available instances introduces severe risk of system crashes and degraded user experience during initial scaling.
As part of Dress4Win's plans to migrate to the cloud, they want to be able to set up a managed logging and monitoring system so they can handle spikes in their traffic load. They want to ensure that the infrastructure can be notified when it needs to scale up and down to handle the ebb and flow of usage throughout the day. Their administrators are notified automatically when their application reports errors. They can filter their aggregated logs down in order to debug one piece of the application across many hosts. Which Google Stackdriver features should they use? The options are Option A, Logging, Alerts, Insights, Debug. Option B, Monitoring, Trace, Debug, Logging. Option C, Monitoring, Logging, Alerts, Error Reporting. Option D, Monitoring, Logging, Debug, Error Report.
To arrive at the correct answer, we focus on the keywords: manage logging and monitoring system, scale up and down, administrators are notified automatically when their application reports errors, filter their aggregated logs down, Google Stackdriver features.
The correct answer is option C, monitoring, logging, alerts, error reporting.
Why is this correct? C. Monitoring tracks infrastructure metrics to trigger autoscaling, logging allows log aggregation and filtering across hosts, alerts automate administrator notifications, and error reporting centralizes and alerts on application errors. Why are the others incorrect? A. Insights is not a core Stackdriver feature, and monitoring is missing, which is required to feed metric data for autoscaling notifications. B. Trace analyzes latency and debug inspects running code, neither of which handles log filtering, autoscaling metric triggers, or notification alerts. D. Debug is used for code-level troubleshooting rather than log aggregation/filtering, and alerts are required for automated administrator notifications.